Um, let's talk types of reactions under organic chemistry, of course. So, here under on types of reactions, we have this one, addition. We have addition reaction, we have substitution reaction, we have elimination reaction, and then we have the last one, esterification. So here, esterification, already we did esterification. This is the addition of an acid. This one is acid, the reaction of acid and alcohol. So acid and alcohol, when they react, they form, in the presence of sulfuric acid, they form ester plus water. So already we know this one, so I'm not going to spend more time on it. So let's focus on these three, but for now I want us to focus on addition reaction. So on addition reaction, here we move from double bond, let's say from double bond to single bond. So if it's addition reaction, you will see a double bond, and then at the end the product is going to be a single bond. So that means we break that double bond and form a single bond, as long as it's addition reaction. So that means now I want us, before we go there, let's check. So here on substitution, this one is from single bond to single bond. So this one's from single to single. So we can say, let's go back to addition. On addition, we can say double bond to single bond. It means that this is addition reaction. So you can say, you can claim it like that if you can. So this one is the double bond to single bond. That means the reaction is addition reaction. So for substitution reaction, since it's single bond to single bond, it means that you can say this is a single bond to single bond. That means it's a substitution reaction. So you can call it a triple S. And then for elimination, we have a single bond, from single bond to double bond. So under addition reaction, we have a single bond to double bond. It means that you have a single bond to double bond. It means that this is elimination reaction. So, but on elimination reaction, we have two types of elimination reaction. We have this one, and the other one is called cracking. I'm not sure about the spelling, but cracking reaction. So this is where we break the longest structure, or the long chain structure. We break it into two simplest short structures. So this one will just break the structure into two, and then the other one will become a double bond, the other one become a single bond, right? So now let's focus on the addition reaction. So on the addition reaction, on the addition reaction, let's say we have C double bond O. So now let's check this hydrogen. Okay, so we are adding something here. Let's say we add H2. We are adding hydrogen atoms. So now let's check. This is the product now. We're going to have these 3 carbon atoms. 1, 2, 3. We break the double bond now. So when we break the double bond, remember, a carbon atom must have 4 bonds around it. So when we break the double bond, now we're going to have a single bond, single bond. Remember, addition reaction is from double to single. So that means it's addition reaction. From double to single. So from double to single. So yeah, we're having all the hydrogens because we're adding H2. So this one, the type of addition reaction, this one, we call it hydrogenation. So it's an addition reaction, but the type of addition reaction is hydrogenation. Why hydrogenation? Because we are adding hydrogen. So it become hydrogenation. Right. So let's have another one. Okay. Can have 3 carbon atoms to make life easy. So let's say we are adding HBr. Yeah. And then now the product. So we're going to have a single bond. We're adding, remember? So we're going to have single bonds. And then the first carbon atom is having 3 hydrogens, right? So this is the first carbon atom. The second carbon atom is having 1 hydrogen. So let me have that one. And then this one was having 2 hydrogens. So now let's check. We are adding HBr. So check, this is what we must do. Since we are adding HBr, we are adding hydrogen and bromine. It means that the first carbon atom must have more hydrogens. So in simple way, the rich get richer. Oh, that one's nice. The rich get richer. So it means that the hydrogen, it is going to bond on the first carbon atom. The hydrogen will bond with the first carbon atom. Why? Because the first carbon atom is having more hydrogens than this one, right? So this one is richer than this one. So the rich get richer, the poor get poorer. Right. So that means now the hydrogen will bond here, and then here we're going to have Br. So now, what type of addition reaction is this one? So check, what are we adding? We're adding hydrogen and bromine, right? So we can say this is hydro for hydrogen, right? And what is hydrogen or bromine? We can say hydro. Since this one is from haloalkanes, right? So we can say hydrohalogenation. Yes. So hydrogen, bromine is from the family of halogens, right? Or haloalkanes. So addition of hydrogen and a halogen, let's say addition of hydrogen and halogen is called what? Hydrohalogenation. So hydro for hydrogen and then halogen for the bromine. It's part of halogens, right? So they become hydrohalogenation. Let's have another one. So this one, oh, we're still adding. Don't forget. Let's not forget. So still remember, we're from double bond to single bond. That means this is a addition reaction. So now let's see. I'm going to use 3 carbon atoms to make life easy. So now let's say we're adding water. Then let's check the product. So the first carbon atom, since we're going to have single bond, from double to single, then it's addition. So we're going to have single bonds, and then the first carbon atom was having 3 hydrogen. The second carbon atom is having 1 hydrogen. The last carbon atom is having 2 hydrogens. Now let's check. Remember, the rich get richer. So that means on the first carbon atom, we're going to put a hydrogen there. We'll put a hydrogen. Since we're adding water, how many hydrogens do we have here? We have 2. That means we're left with OH now. So we are going to put our OH on the second carbon atom. So now it became an alcohol. So now, what is the name of this addition reaction, or the type of addition reaction is this one? So check, what are we adding? We're adding water, right? So when you drink water, you are adding water into your system. So that process is what is hydration. So that means you are hydrating here. You are not dehydrating. This is hydration. So the part of the type of addition reaction, this one is hydration. This is the addition of water, right? So let's say we have another one. I'm going to stick with the 3 carbon atoms. It doesn't mean that always it will be 3 carbon atoms. I just want to simplify life. So now let's say we are adding Br2, right? So now let's check the products. So since it's addition, we're going to have a single bonds everywhere. Single bonds, single bonds, single bonds. So, I made a mistake here. So since here we're adding bromide, we have 2 bromides there, Br. So, and we don't have hydrogen. It means that we put the bromides wherever we want. So here we're going to have Br, and here we're going to have Br. So now, what type of addition reaction is this one? So what are we adding here? We're adding bromine, right? So we can call it bromination, or you can say halogenation, because it's part of the halogen. So you can say halogenation. So we'll accept one of them. It's either you say bromination. Bromination, it means that you are this is the addition of bromine. Halogenation, it means that is the addition of a halogen, and bromine is part of the halogens, right? So it's either you write bromination or you write halogenation. So let's have the last one. Let's say we have C. Okay, now let me have 4 carbon atoms so that we balance life. Also, we might say always 3 carbon atoms, 3 carbon atoms. Okay, so now let's say we're adding Cl2. It's not always bromine, right? So we have a lot of halogens. So now let's check the product. We have 4 carbon atoms. So 1, 2, 3, 4. So I'm doing this because it's addition. At the end, we're going to have a single bond. So now the first carbon atom is having 3 hydrogen atoms. two hydrogen atoms, and then here we're having one, here we're having two. So we're adding Cl2. So we can put the first Cl here and the second Cl here. So now let's check what is the type of the addition reaction is this one. So first, what are we adding? Chlorine, right? So you can say this is chlorination, or you can say it's a halogenation. Halogenation. So it's either you say it's chlorination or it's halogenation. So that would be up to you. So now let's say it's enough for about addition reaction. Now let's talk about the substitution reaction. Substitution reaction. So for substitution reaction, remember we said it's from single bond to single bond. It means that this is substitution reaction. So these are S's, SSS, triple S. Oh, we can call them S's, right? Kidding. All right. So since it's from single bond to single bond, check what's going to happen. So let's say we have these ones. So, okay, now what's going on here? We are adding something here. Br2. So let's check the product. So since this is substitution reaction, oh, I forgot to mention something on addition reaction. Please forgive me. So I forgot to mention this thing, what you call but we're using a platinum here as a catalyst, not a catalyst, sorry. A reaction condition, yes, or we can say catalyst. So the condition here, it says we use platinum in addition. As long as this is addition reaction, we use platinum. You can say PT, the formula, right? So you'll forgive me for that one. Okay, so here we are using a strong base here, NaOH. We are using a strong base. So now this is the reaction condition, don't forget. So let's check the products now. Since we're having 3 carbon atoms, remember it's from single bond to single bond. So this is the first hydrogen, the first carbon atom. 1, 2, 3, 4. Oh, it's 3, sorry. So here we can have hydrogen. And then here, let's put Br, since we are adding Br2. And then here, hydrogen. Plus, since we substituted hydrogen with Br, that means that hydrogen now is coming here, we're bonding with what? With that Br. So now, at the end, we are no longer having Br2, we are having HBr. So we substituted this hydrogen with the bromine there. So let's check another one. Okay, let's say we are adding H2O. So let's check the product. This is the reaction, the condition. I forgot to mention it under addition reaction, but since I'm glad that I didn't forget to remember it. So okay, here let's check the products. Single, single, single. So the first carbon atom, that one, that one, that one. And then, now, let's substitute the hydrogen here with what? Since we are reacting with water. So, we have OH here, and then plus, we're going to have what? H2. Why H2? Because we substituted the hydrogen here with what? With OH. So, that hydrogen now, it's here. So, that's how we perform the substitution reaction. So, we can try another one. Single, 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 single. We can have Br, and then we are reacting with H2. So the product now, NaOH here. So the product now is going to be 4 carbon atoms. Now check Br is in carbon atom number 2, right? But we are adding H2. So that means now we want to substitute Br with H. We take one H here and put it here. So we're going to have H here. That means now at the end we're going to have a plus HBr. Why? Because we substituted this Br with what? With one H here. So the other H now is bonding with Br. So these are the products from this reaction. So we can also see, let me have 3 now, Cl. So, let me say plus H2O. Okay, can say that. And then the product is going to be, let's check. 1, 2, 3, right? So 1, 2, 3, and then the first one's even 3 of them, even the last one. So let's check. We are adding water now, but we have Cl. So that means we're going to substitute Cl here and put what? We're going to put OH here, and then plus, it was H2. We took one H here. That means we're left with 1. The O is there now, so we substituted this one with OH. That means now we're going to have HCl at the end. So this is how we do substitution reaction. So on the next video we're going to continue with elimination reaction, including the cracking stuff, and then we add esterification on top. Thank you, and please don't forget to subscribe.